Welcome back to lesson number 5. This is lesson 5, part 2. And so in part 1, we were talking about stretches. And remember, the stretches we're talking about are expansions or compressions. And both of those are going to be going about the x and the y axis. So we're just going to go through this table, labeling the table, and thinking about our a or our b values and whether they're going to result in a horizontal or vertical stretch. So if we're looking at our a value, where a is greater than 0 but less than 1, and if we look at this graph, this is going to result in a vertical stretch, and this is going to be a vertical stretch about the a value, and that's going to be about the x-axis. So it's going to be by a factor of a about the x-axis. And so if we look at our new graph here, we can see that it's been compressed vertically, and all our y values are going to change, but our x value is going to remain the same. When a is greater than 1, again, if we're talking about a, then we're talking about a vertical stretch. And so our vertical stretches are going to occur by a factor of a, and again, it's going to be about the x-axis. Still thinking of a, but this time a is less than 0. Remember that it's going to be a vertical stretch again, and if it's less than 0, that's going to result in a reflection in the x-axis. And the vertical stretch is also going to occur about the x-axis as well. So that's when we're talking about stretches involving an a value. But what about stretches involving a b value? So if we look at the graph of y equals f of x over here, and I have a value of b which is greater than 0 but less than 1, this is going to result in a horizontal stretch. So it's going to be stretched horizontally by a factor of, in this case, 1 over b. And this is going to occur about the y-axis. And next, if b is greater than 1, there's going to be a stretch horizontally, again by a factor of 1 over b, and that's going to be about the y-axis as well. And finally, if our b value is less than 0, this will result in a reflection in the y-axis. And if we look at our points, we are being reflected in the y-axis, and we're also going to have a stretch that's going to occur horizontally about the y-axis as well. Right, so those are our stretches. Next, let's work through some examples here. So the first thing we want to do is write the replacement for x or y and write the equation, the image of y equals f of x after each transformation. And so a horizontal stretch by a factor of 6 about the y-axis. And so if I'm thinking about if it's about the y-axis, then I know my values of x are going to be changing. And if it's by a factor of 6, it's my values of x, then that's going to result in me multiplying my values of x by 1/6. In which case, my new function is going to be f of x will turn into f of 1/6 x. If I have a vertical stretch occurring by a factor of 1/5 about the x-axis, then that means my y values are going to be changing by a factor of 5. And so 5y, if 5y is equal to f of x, this is going to result in y equaling 1/5 f of x. And so if I have a reflection in the x-axis and a vertical stretch above the x-axis by a factor of 3, if it's a reflection in the x-axis, remember that the reflections would result in my y's being mapped to negative y. But if I have a vertical stretch about the x-axis by a factor of 3, all my y values will be mapped by 1/3. And so if I were to combine these two mappings, I'm going to be left with y mapped to 1/3 y. And so I'll replace my value of y with negative 1/3. left with f of x, and my final equation would equal negative y is equal to negative 3 f of x. This negative 3 comes from dividing that left side by negative 3. And finally, a horizontal stretch by the y-axis by a factor of 1/2, and a vertical stretch about the x-axis by a factor of 1/4. So first we're going to begin with our stretcher about the y-axis, and so my values of x will change. If it's by a factor of 1/2, they're going to change by 2. And my x, if my y values, if it's a vertical stretch about the x-axis and it's a factor of 1/4, my y values will be mapped by 4 as well. So what we're left with is 4y will be equal to f of 2x. All I'm replacing are my x and y values that are being changed due to my mapping. And if I divide this side by 4 and the other side by 4, I'll be left with y is equal to 1/4 f of 2 of x. And my last 3 examples here. So how does the graph of 3y equal f of x compare with the graph of y is equal to f of x? Well, the best thing to do here is think about what's going on with the y values. They're being mapped by 3y, and if I were to rearrange this and replace 3y into f of x, then I'm going to have to divide this by 3, which will leave me a 3 is equal to 1/3 f of x. If I have 1/3, this will result in a vertical stretch. This vertical stretch is going to occur by a factor of 1/3. And if it's a vertical stretch, it's going to be about the x-axis. So what happens to the graph of the function y is equal to f of x if you make these changes? So if I replace x with 4x, well, if I replace x with 4x, this will result in a horizontal stretch. A horizontal stretch about the y-axis by a factor of 1/4. What if I replace y with 1/3 y? So y is being replaced with 1/3 y. Well, this will result in a vertical stretch about the x-axis, and that'll be by a factor of 3. And if we look at this, this would become y is equal to f of 4 of x, hence our factor of 1/4. And this would become y is equal to 3 f of x, hence our factor of 3. Now what if I replace y with 6y and x with 1/3, with 1/3 x? Well, for my function is going to become 6y over here, so it's going to become 1/6 f of 1/3 of x. And so that'll be a horizontal stretch by a factor of 3 by a factor of 3, and that's going to be about the y-axis. But we're also going to have a vertical stretch by a factor of 1/6 about the x-axis. All right. Last question. If I sketch y equals f of -2 of x, what's going on here? Well, first of all, my x is going to be mapped to negative x. That's where that negative sign comes in. And they're also going to be mapped to 2x. And so if I were to combine those, the mapping that's occurring is going to be x to negative 2 of x. And so this point here is going to stay the same. But the first thing I'm going to do is, if I look at my x values, they're going to be mapped across my x-axis. All right, so this will be mapped across my, sorry, not my x-axis, my y-axis, and then they're going to be stretched by a factor of 1/2. So I have a horizontal stretch by a factor of 1/2, and that's about the y-axis, and a reflection in the y-axis as well. So let's do our horizontal stretch first. If I'm looking at this point here, I am at 4 and 4. So remember, if it's my x values I'm thinking about, I don't really have to worry about my y values. So first of all, if I'm at 4 and I multiply it by a factor of 1/2, that'll take it to 2, and then I'm going to have to map it into a reflection on my opposite side. Same with this point here, I'm at negative 4 and 2. My y value will stay the same. So multiply it by a factor of 1/2 and then map it to my other side. So I got these points, now let's focus on these ones. If I'm at negative 6, I'm going to have to divide it by 2, multiply it by 1/2, and then map it to my opposite side. And if I'm at 5, divided by 2, bring me to 2.5 and map to the other side. Right here. And my last point, if I'm at, let's see, at 6, divided by 2 takes me to 3, and map to the other side will take me to negative 3. And so when I combine these points, you are going to get a graph that looks something like that. And this is going to be y is equal to f of negative 2x.